you'll get an email, and the email will have a link in it. You at Several links, as a matter of fact. There's a link where you can get watch this again. Um, there'll be a link where you can get the slides. Am I right about that, Alexis, or do they have to email you for that, or do we post that at a link?
As of right now, they'll email me and I'll send them the slides.
Aha, okay. So to get the slides, then you'll need to respond to that email and just say that you'd like a copy of the slides. So there'll be a link there. If you're wanting to get continuing education credits, there'll be a link where you click and you take a test, and you pass with 70%, and you'll get your continuing education credits. And then there'll be a link with a survey. We do appreciate the feedback. What you liked, what you didn't like, also suggestions for other topics we could cover that's also quite welcome. So we're 3 minutes past the hour. It's about usually the time when I start. But I still hear the beeping, which means that people are coming in. So I'll maybe give it another minute. This is like when you make popcorn in the microwave, and you're supposed to listen for the popping to sort of stop, and it hasn't stopped today. So we'll give it like another minute and then hit it. Okay, I don't hear any beeping. Okay, I think we can get going. So there's a beep. Okay, we're going to get going anyway. So for everybody who's here, welcome. We hope you're having a great Thursday here in this August. Here in Texas, it's sunny and hot. We've had a bunch of days above 105. So I think today it's supposed to be a little cooler, maybe 104. We'll see. In any event, I'm Mike Riddle. I'm president of InCab America, and a long time uh, uh, working in the realm of fiber optic cables and electric utility applications and engineering. So anyway, I'm your host today, and again, welcome. Today we're going to be talking about OPGW installation. So this presentation is RCEP compliant. This agency registered continuing education program, and we meet their standards for giving continuing education credits. So that just means we meet their standard. It does not mean that they endorse our content in any way, shape, or form. So the course purpose today, as I mentioned, is to talk about how you install OPGW. So we have some specific learning objectives, and you can see them here. I will not read them to you because I'm sure you can read them. We're going to look at cable specifications and stringing and all of the equipment and how you set it up. So our agenda today, we've already done the introduction. We've discussed the learning objectives. I'll give the presentation, and that's going to last about 50 minutes, and then we'll have time at the end for questions and answers. So if you do have questions, please hold them to the end. We'll try to make it so you can just ask questions, but if for some reason like we can't enable your microphone or it's not working or whatever, you can always submit questions via the chat. So you should see that somewhere at the top of your screen. Click chat, type your question, and I will answer questions as I can. Okay. During those questions, let's please keep them on topic, so not discussing business or other matters. And now let's get going. So Today topic, installation. We're going to start with stringing. So I want to, even before I begin the actual talk of stringing, mention safety. So there's nothing in my presentation that is intended to counter any applicable federal, state, local, industry, or your own company's safety rules and practices. So you still need to follow those. Our cable manufacturing guidelines don't supersede any safety rules or policies or procedures. And you do need to keep safety in mind for yourself, the general public, and your company's personnel. So safety is number one. So before you actually begin OPGW installation, you got to get the reel to the field. And so I wanted to begin today with discussing proper reel handling because reels are often not properly handled. And so that can initiate problems before you even begin the actual stringing process. So as you see here on the illustrations, you always want to lift a reel from the side and from its bottom. If you do find yourself needing to use a crane or a hoist of some type, what you have to do there is you have to use a hoisting bar or a lifting bar, basically a steel bar through the arbor holes of the reel. And then you see here a spreader bar that's being used to further lift the reel well. In contrast, you don't want to run straps through the arbor hole like you see in this illustration. You certainly don't want to do what you see here or here. And then this spreader bar is important. If you don't have the bar at the top and you let straps go from the axle just up to some lifting point, if they put pressure on the flanges at the top of the reel, that can push the front flanges in, which means they'll bow out at the bottom, and that can disrupt the packaging of the cable. And nothing good can happen from that. Nothing good can happen, and some bad things can happen. If the packaging gets loosened up enough, then when the cable is paying off during the stringing process, the cable can kind of suck down below the outermost layer. And if it does that, it can get stuck. And if it gets stuck, you're trying to continue to pull, it's going to try to pull out, but it can just end up more stuck. And again, bad things can happen up to and including outright damage of the cable or the reel. So this concept of using an axle with a lifting bar above it, as you see in this small illustration, that's what you need to follow. It's important that when reels are on the ground that they be chocked. Um, if you have to roll a reel for some reason, like to move it for a few feet, you can do that, but it needs to be a smooth, flat surface. You certainly don't want to be rolling a reel on rocky ground, for example. Again, nothing good can happen and some bad things can happen. It's much better to lift a reel as you see in the illustrations here. And then the big thing, and this still gets done, it always amazes me, never, ever, ever put a reel of OPGW on its side. You know, this cable is relatively heavy. There are some cables, smaller reels, and lighter cable. Maybe you can get away with doing that. But by the time you're talking reels that are 48 inches in diameter or more, so 4 feet or more, you don't want to do that ever. Never, ever, ever. And assuming you don't damage the reel in the process of flipping it like that, you again risk causing the cable itself to shift, which again, nothing good can happen from that. And then you got to later stand it back up. And the standing it back up process is even more likely to break one of the flanges or damage one of the flanges than just tipping it over like you see in this illustration here. So just never ever do that. Leave the reels standing on their flanges. And then I'll go ahead and just quickly comment. The illustrations are showing a reel that's been lagged, but I actually prefer reel wrap. It's comes in different colors, but think of it as plastic corrugated cardboard. Its construction, it's like that of corrugated cardboard that you see in, say, a corrugated cardboard box, but it's made out of a plastic material instead. And what's good about that material is that it forces forklift operators to go flange to flange, like you see in these little illustrations here. Wood lagging in general will not support the weight of a reel, whether it's OPGW or conductor or any other type of cable. It's there mostly to protect the cable from things like impact. So if you the reel wrap makes the forklift operators go from one flange to the other so that you get a good clean lift. If they don't make sure the forklifts go all the way to the far flange, then when they try to lift up the cable, the wood can break and the cable gets damaged and everybody has a bad day. So that's why we recommend reel wrap versus wood lagging. So again, before you even begin the actual stringing, it's a good practice to check the pull because this is your last chance to make sure that there was not some kind of potential problem. The general guideline for pulling in OPGW, and really this applies to other types of cable as well, but today our topic is OPGW, so I'm applying it specifically to OPGW, is 20% of the rated breaking strength of the cable. That's in the IEEE 524 standard, which is the standard for installing aerial cables. And it's the standard that, or the value that we use as well, 20% rated breaking strength. But you do need to check this because some suppliers will only allow 15% rated breaking strength or less. I've seen 10. And of course, if you exceed what the manufacturer is recommending, then you risk voiding the warranty on your cable if something goes wrong. So that's your risk there. So it's worth it to check it. We also think that you should check the horizontal line angle changes, and we'll show both of these how to do them. So first up, in order to do that, you need to know the rated breaking strength of the cable. And you're going to get that from the cable data sheet. So this is one of our data sheets, but other manufacturers, every manufacturer, in fact, is going to have a data sheet on their cable. So you will find the rated breaking strength on it. If you don't have the data sheet, then you need to get it from the cable manufacturer. Later, we're going to see that the cable diameter is going to be a factor as well. So for stringing purposes, these are the two overwhelmingly most important things that you need to know: the cable diameter and the cable rated breaking strength. So how do you check that? In general, the tension at the payoff, so from the reel, is going to be about half your design tension at 60 degrees Fahrenheit under initial unloaded conditions, what people often refer to as everyday conditions. Then the tension on the pulling side is going to be that tension divided by 0.98 raised to the n. And n is the number of structures that you're going through. So what the heck does all of this mean? Well, this 0.98 raised to the n is allowing for the fact that each stringing block is going to add a little bit of friction to the pull. And I'm going to use the term stringing block most of the time, but there's also shiv, pulley, traveler. There are different terms. They all mean the same thing. The wheels that you're pulling the cable over as you pull it in during the stringing process. So each one of those adds a little bit of friction to the pull. So the tension on that payoff side is going to be less than the tension on the pulling side. By the time you're at 20 structures, that difference is 50%. So 50% more tension on the pulling side versus the payoff side. And it's close to a factor of 2 by the time you're at 30 structures. And I see projects routinely that have 20 structures or more, and even regularly see projects with more than 30 structures that you're pulling from. So that's a significant difference. You need to take a look at it. So just as an example, to illustrate this point, if I had a 19,500 foot pull and I was going through 30 structures and the cable rated breaking strength was 20,000 pounds, the design tension 3,000 pounds, I would expect the tension at the payoff to be about 1,500 pounds. Might be a little bit more, might be a little bit less. So the estimated maximum tension using the formula on the previous slide works out to one. So this 0.98 raised to the n works out to 1.8. So 1.8 times 1,500 equals 2,700 pounds. 20% of my rated breaking strength was 4,000 pounds. 2,700 is less than 4,000. So you're okay. Now, this is approximate. So what if this came out to 3,900 pounds? Well, you might want to be more careful because it could be, it's only an estimate, might be a little bit more, might be a little bit less. So just know that if it was 4,100 pounds, I wouldn't necessarily say, oh no, you can't complete this pull. I will say that you need to talk to the manufacturer and that you need to be very careful during that pull. So it's a guideline. It's not some kind of like law of nature. And by the way, another way that comes at this from a slightly different way, but basically ends up in the same place, is Wagner Smith has a line pull calculator on their website. You'll use slightly different information, but you end up in a very similar place as far as estimating what the maximum pulling tension is going to be. And then I just want to repeat this for the metric units for our international customers. I won't actually read through this. Just know that this is available if you want to look at the slides later and check the math and whatnot. Okay, so we'll keep going. So I mentioned also that you want to check the horizontal line angle change. So our guidelines are for plain center stainless steel loose tube type cables or aluminum clad center stainless steel loose tube type cables and aluminum pipe type cables. So basically any cable where the fiber is actually in the center of the cable, you want to limit your total horizontal line angle change to less than 270 degrees, of which only one can be more than 90 degrees. For a stranded stainless steel loose tube type cable, you can go up to 360 degrees, of which two can be greater than 90. You can ignore angles less than 5 degrees. And this too is another example of something that is a guideline, not a law. Again, you need to check with other suppliers because they might be more restrictive, meaning these numbers might be lower, or they could be less restrictive. So you should check. And anytime you end up with a problem, again, you should check with the manufacturer and coordinate with them on the pull. Oh, and I forgot. So to illustrate this, so if I had a line and I had I'm using a type S cable and I have 10 degree angles. Well, 10 times 10 is 100. That's less than 360. No problem. So that's the concept. You just total up the angles. You don't need to make a distinction between angles to the left and angles to the right. Effectively just use the absolute value of the angles and add it all up and follow these guidelines. So you've checked your pull, everything looks good. Now you're getting ready to actually do the pull. So for OPGW, the only approved method of stringing is the controlled tension method. I'm not even going to mention the names of the other types of stringing that are theoretically possible, because they're not theoretically possible, because you can't use them. Use control tension only, and it doesn't matter if it's our cable or somebody else's cable. Everybody says use control tension method only. And in this method, you're using a bull wheel tensioning device at the payoff end and a puller from the pulling end, and the two working together maintain constant cable tension during stringing. And again, this is, you can see this in IEEE 524. Here's what that looks like. So I have a cable reel on a reel stand. I have that tensioner with these bull wheels. It's basically like a capstan. Uh, and what it's going to do, its purpose is to keep the tension constant throughout. So then I got the cable going up, it's going through these stringing blocks or traveler shows, whatever you want to call it. Sometimes you'll see an anti-rotation device used. We'll talk about that later in the presentation. And then you've got your pulling line, and then you've got a puller. To connect the OPGW cable to the pulling line, you will use a pulling grip and swivels, and we'll talk about all of this stuff as we continue through this presentation. First up, the bull wheel tensioner. Here's some typical units that you'll see. The requirements is that it needs to be capable of maintaining constant tension and speed. The grooves need to be neoprene lined, as you see in these pictures here, and in excellent condition. What does excellent condition mean? It means clean, no scratches, gouges, or grooves worn into the surface. Visually, you should be able to look at it and it should look good. I do tell people to use the mental, I emphasize mental, bloody hand test, because remember, we're about safety here. So you don't want to do this for real. You just want to use your mind to imagine that if you put your hand in the groove and that bull wheel was spinning, if you think your hand would end up bloody as part of that process, then that's a tensioner not to use. You want your hand to come out clean, maybe a little dusty, but basically no blood. That's the point. But again, it's a mental test only. We're also going to talk about the effect of lay direction, because in the United States and many countries, OPGW is made with left-hand lay, whereas conductor is made with right-hand lay. Just realized I should have had a slide to illustrate that. What can I improvise here? Y'all see me, correct?
Yes.
You see my little picture? Okay, so I take my hand, I point my thumb in the along the axis of the cable, and I look at my fingers. If they curl with the lay of the cable, in this case, I'm using my right hand, that's right hand lay. If they don't, then it's left hand lay. And I can verify that by then taking my left hand and putting the thumb in the direction of the cable and looking at how my fingers, do they curl with the cable? And if it's with the cable, then it's left hand lay. I'll improve the next time we do this and add an actual illustration of that. Sorry, I didn't think about it. Best I can do today. But anyway, so the point is that conductors in all countries are different from OPGW. They're the opposite. So outside the United States, you'll see conductor left-hand lay and OPGW right-hand lay. So in theory, that means that here I'm illustrating right-hand lay conductor. The reeving of those bull wheels would be like you see here in this picture, left to right. And notice the offset here. So the back set of wheels versus the front set of wheels, there's a shift. Those front set are shifted to the left relative to the back. So in theory, you should change that from conductor to OPGW. So instead of going, oops, so from conductor left to right, you should go right to left. So reading left to right, I wrote this wrong, and offset to the right. Yeah, I made a mistake there. I should have said you should go right to left, and then the offset should be to the right. That part is correct. And the reason that you do that is that in theory, you could get de-stranding, or think of it as unraveling, or it's often called in our industry bird caging. So the outer strands could loosen up. But we run into reality. In my experience, which is now going on close to 30 years, I've seen around 50% of tensioners, maybe more, it's not possible or practical to reeve in the opposite direction. Sometimes you can't physically change the offset, for example. Sometimes just the way that it's laid out with the cable guides on the tensioner, you couldn't reeve it the opposite way. And then in many cases, I've just seen the requirement is just overlooked. The crew doesn't know that you're supposed to change it. So um, I observed that over the course of my career, and I realized I've never seen an actual problem caused by the incorrect reeving or offset. I don't know why. It's one of these theoretical things, but what I'm saying is I don't really see it in the field. It could be because of the materials that are used, aluminum clad steel and aluminum alloy wires used on the outer layer of OPGW. They're stiffer than the type of aluminum that's used on conductor. So because they're less ductile, maybe they're less susceptible to unraveling or bird caging during stringing. But even on long pulls, I've never actually seen a problem from this. It could also be the consequence of how the cables are made with good wire preforming beforehand. Bottom line is, I don't really know. I've just never seen it be a problem. And then I have to fall back on kind of a bottom line thing again. If you come to me and you tell me that you have a piece of equipment that you want to use and you can't change the reeving, I'm going to tell you, yeah, just let it go. And yes, I'll send you an email or put it in writing, no problem. But you've obviously got to check, because maybe another cable manufacturer feels different. Maybe their experience has been different. So it's something that you have to check. And for now, I just want you to be aware of it. Yes, you should at least be aware of it. So next up, the reel stand. Typical pieces of equipment here on the left. Obviously, it needs to be capable of supporting the gross weight of the reel, right? If you have a reel trailer that's rated for 2,000 pounds, and you've got a reel that weighs 4,000 pounds, you're asking for trouble. So check that. You want the axle and the braking mechanism to be such that the cable will rotate smoothly. One of the things you're going to hear throughout this presentation is how important smooth is. You don't want the cable jerking around, basically. You don't want the reel to free spin. So if the pull comes to a stop for any reason, you don't want the reel to keep spinning, because what's going to happen? The cable is going to loosen up. If it loosens up too much, you can have a big problem. If it's only one or two wraps, maybe not a big deal. But if it's an entire layer, you're asking for trouble. You should be, in order for it not to free spin, you should be able to get a little bit of back tension. Now, I've never seen a piece of equipment where you could actually measure that. People want to know, well, how much back tension? Well, 50 to 100 pounds. Okay, but how can you measure that? Well, you can't. So the reality is it boils down to hand tight. So when the cable is going from the reel stand to the bull wheel tensioner, you should be able to kind of feel some tension in it if you hold the cable. Uh, so, imagine grabbing the cable. You should feel it give you some resistance and not just flop around as if it had no tension at all. So hand tight is what we call it. Next up, the puller. So the puller, typical pieces on the left, needs to have sufficient working capacity for the pull. So you've done that calculation what the maximum pull is. So you want to make sure that it's got that capability. If you're looking at a pull that's going to require 3,000 pounds, then your puller needs to be capable of pulling 3,000 pounds. It's that simple. Also, you want to make sure that the drum has the volume for the pulling line that you're going to be taking out as part of this process. And you want it to have good torque. So that's going to help make it be smooth. And again, here we talk about smooth again. You want it to operate smoothly when it starts and stops the pull. You don't want chatter, like it's kind of jerking, it's working hard to get going. You want smooth. So you had to connect the OPGW to a pulling rope. Let's talk about that pulling rope. You want a good quality braided pulling rope or pulling line. Should be close to your diameter of your OPGW, reasonably close. Obviously, sufficient strength again matching the conditions of the pull. And there are so-called uniline out there with no torque, and that's what works best, is a no torque type pulling rope. So I get this question asked a lot. What about using an existing shield wire to pull in OPGW? You can do that, but you need to carefully inspect that before the pull. These days, drones are a great way of assessing the condition of an existing ground wire that you want to use to pull in another cable. But there's also assessment equipment available. Connectrix out of Canada, they have a little piece of equipment that you use. You pull it along an existing ground wire, and I think it works on X-ray, and you can examine that cable and see what condition it's in. What you're basically looking for is it strong enough, or has broken strands, like maybe from lightning strikes or corrosion, another problem, have that weakened it to the point that it's potentially going to break during the pull. Obviously, that's bad. You will have a bad day if a pulling line or an existing shield wire that's being used as a pulling line breaks during the pull. So if you decide it's okay, then during the process, you've still got to monitor that cable closely. Because what can happen is there's no broken strands when you start, but then you start pulling on the cable, and then some strands can break. And if they break and bend, which is likely to happen, then the edges of the broken strands can damage your sheaves, which in turn can then transfer to your new OPGW cable that you're pulling in. So I always tell customers, I really ask this question, is it really worth the risk? I think not. I think because of the safety concern and your investment, protecting your investment in your new OPGW, I really think it is better to go ahead and pull out an existing shield wire. You can use it to pull in a new pulling line. I'm not going to complain too much about that. And use that, then use the pulling line to pull in your OPGW. But at the end of the day, you can do this if you really want to. Just be very careful doing it. Next up, pulling grips. So you will connect the OPGW to a swivel, and then maybe to an ARD, or then to the pulling rope with another Kellums type grip. So these pulling grips are important. High quality woven wire type grip, commonly called a Kellums grip. There are a number of companies that make them. They basically look like what you see here in the picture on the right. You'll need one obviously sized for the OPGW and another one for the pulling rope itself. If you've used about the same size, they'll probably be the same, meaning if you've used a pulling line close to the same diameter as your OPGW, it'll probably be that your Kellums grips are the same, two of the same type. Again, strong enough for the pull, and the big thing here, must pass freely through the blocks. If it jams up, bad things can happen. Swivel. You want a high quality ball bearing type double axis swivel. Here's a picture of one here. Again, strong enough for the pull and able to freely pass through the blocks. So in this illustration here, I've left out an ARD, but this is the basic concept. Your OPGW cable, you've got your pulling grip, it's connecting to a swivel, which in turn is connecting to another Kellums grip, which is connecting to the pulling line. So what the swivel is doing is it's separating any torque on the OPGW from any torque on the pulling line. Keep going. Now, stringing blocks. Lots of other names, as I mentioned already, for those: shivs, travelers, pulleys, whatever. But these are the single most important tool used during stringing. And it's absolutely essential that they rotate freely, that they have a smooth, clean bearing surface. And recall that mental bloody hand test that I talked about. Same concept here. If you would not put your hand in the groove of this block and then have it spin for fear of having your hand come out a bloody mess, don't use that block. Now, this is actually going to be a little bit controversial, because most OPGW suppliers are going to tell you to use lined blocks, lined with neoprene or urethane. My experience has been that I have had much better results with unlined aluminum blocks than I have with lined blocks. In fact, every time I've had problems with pulling in the course of my career, it has been with lined blocks. And every time the solution to that problem was to tell the customer to switch to unlined aluminum blocks. Again, my experience, other manufacturers will completely disagree with that. They will say you must use lined blocks. I'm sorry, you have to check. In my experience, what happens is that OPGW is relatively light compared to conductor. And so in the line blocks, urethane or neoprene gives enough friction for the cable to ride up in the groove, and then bad things happen. Right? If it rides up and starts dragging the cable along the frame of the block, right, the cable is in here, but if it rides up the side of the groove and ends up around here, dragging along the frame of the block is going to damage the cable. That happens when there are slight deviations from true straight path. So even just a little bit of an angle or an offset can cause this riding phenomena. So for that reason, I tell customers I prefer the unlined blocks. But regardless, you should never ever use unlined steel blocks. In general, these blocks tend to be too small anyway. It's just another story. We'll come back to small sizes later. So my recommendation, again, unlined aluminum blocks are best, but you have to check if you're using somebody else's cable. Okay. There's a newer type of block that's available by a company called Jameson. They have this aerial buddy block, and it's plastic. And those blocks are great. As my father would say, the greatest thing since sliced bread. They have a 24-inch size. They have a limited number of sizes. I think there's just two, 12 and 24. And the 24 looks to me like the one that would work 80% of the time with OPGW. You got to check, though. Again, sweat the details. So how do you size your blocks? Well, if you have no other guidance, you would just say 40 times diameter. And this is what I think is shown in the IEEE 524, pretty sure about that. But you can get some relief. So for the first, last, and any angles greater than 45 degrees, aluminum pipe type cable, 40 times diameter still, center stainless steel loose tube type cable, also 40 times diameter, but a stranded cable, you can not get away with, it'll work quite well, 30 times diameter. All other structures, so all the tangents in between, pipe type cable, 35 times diameter, same for the center tube type designs, and stranded 25 diameter. But some manufacturers are going to stick with the 40 times diameter in all cases, so you're back in the realm of you've got to check. And 40 times diameter is safe to use. You know, bigger in general, at least in this context, is better. Maybe not, I shouldn't say in general, but in this context, bigger, you know, you can always use a bigger block than a smaller one. So as a general rule, but the larger blocks do create the problem of practical problems of availability and the difficulty of getting them hung, because they start to get really heavy. And so getting them mounted can become a little bit of a struggle because of the weight. Big thing to focus on is root diameter. The block manufacturers will talk about an 18-inch block, but and the cable manufacturers will say, no, that's not an 18-inch block. That's probably a 14-inch block, meaning the root diameter. So you got to focus on the root diameter, not the frame diameter, which is what they go by. Look at the root diameter. These numbers are based upon that. And 40 times cable diameter means exactly what it says. So if I had a cable and the diameter is 0.5 inches, 40 times that would be 20. So I need a block with a 20-inch root diameter. And the block manufacturer is probably going to call it a 24-inch block. So beware of that. Okay, you also, with blocks, need to support them at angles greater than 30 degrees. What you're trying to do is keep the OPGW in the same plane as the block. Because if you have this situation, what does intuition tell you is going to happen? What's going to happen is that the cable is going to tend to ride up and could then drag along the side of the frame. That's bad. So you need to support the block to try to keep the cable in the same plane. You can do that with a support like a chain or a rope tied to the frame like you see in this illustration and secured above the block, or you can support from beneath the block. And then, you know, I think of things I wish I had thought of a little bit earlier. Because of this situation, what you're generally going to want to do is have the block above the plane of the cable prior to the pull, so that when the tension comes on the cable pulls up and ends up in the same plane as the block. This system here, you can rig up something so that the block can float a little bit. That's ideal. You know, you get bonus points for being fancy and cool there. But I've only seen one utility who does something like this. But again, what you're trying to avoid, or at least minimize the possibility of, is the cable riding out of the groove and then dragging along the frame rather, of the block. So, and then there are bad blocks. Never, ever, ever use anything like you see here. And I see customers who try to gang blocks, and I'm going to explain why this doesn't work. So this is like two separate blocks that have been connected via a yoke plate with some other connection between them as well. No, not good, or not necessary. I'll explain more in a minute. This is a so-called banana block. Absolutely no good. I have seen this type of block wreck more OPGW and even some ADSS as well cable than anything else out there. And this is a variation of this banana block concept. It does not work. Here's why. You need to have a certain bearing surface over a block. So if this is a block and the cable goes over it, it makes contact with the block and then continues over the surface of the block before it breaks that contact as it's continuing on. So that area I refer to as the bearing surface of the block. You can do this geometrically. You could also do this mathematically. If you have a certain size and you then block, and then you take that and you add two of them, the total bearing surface just ends up being divided across those two blocks. It doesn't get more bearing surface. And if you do 3 blocks, you just divide it across 3, but the bearing surface is still the same. So if this original bearing surface is not sufficient, then it doesn't matter how many blocks you use, it's still not sufficient because of this reality here. So you've got to use a block that's the proper size. There is sort of an exception because sometimes the way a tower is designed, like maybe the cable for some weird reason is going through the middle of it, or just yeah, because again, it's related to structure design. Sometimes you need a block on one side of the structure and a block on the other side of the structure. So you are using 2 blocks, but they still have to be the proper minimum size. Right? So if I work out a block and it's supposed to be a 14-inch root diameter, again, root diameter is critical, then I need a 14-inch on both sides of the structure. I can't use a 12-inch on both sides of the structure. So I hope I'm making sense there. Even in this situation, each block must have the sufficient bearing surface, so each has to be the proper minimum size. Okay, next up. So we've basically talked about the tools and equipment for doing the stringing. After you complete the stringing, you've got to do the sagging. You've got to bring the cable up to sag, and then you got to do your clipping in, and you'll need a completely different type of grip for that. Here are your options for that. So first up, pocketbook type grip, often called a come along, and you see an illustration of that on the right here. It's a great choice. Your other choice is to use a guide grip or a formed wire grip. That works too. And this is a case where there are trade-offs. So pocketbook type grips are more expensive. They're around $500 each, and you need to plan for a couple, 2 to 4 weeks to get them. Now, pocketbook grips are generally sized for one diameter only. So if you got a cable that's 0.5 inches, you have a pulling grip, a come along for 0.5 inches. If you use a second cable that's 0.6 inches, you got to have a completely different grip for that. It can be used in that groove is good. You can keep using it. Well, I mean, other things too. The bail has to be good. The bolts have to be in good shape. But basically, as long as it's in good shape, you can keep using it. Formed wire grips are relatively cheap. They can be well under $100, and they're often in stock at distributors here and there. They'll cover a range, so you might have one grip that covers both 0.5 and 0.6. But does have some limitations. One of them is that you can only use this type of grip 3 times. So you've got an initial and 2 reapplies, and then you've just got to throw it away and grab a new one. And some of the manufacturers of these products don't agree for them to use their product as a working tool. One manufacturer in specific, which I won't name, but begins with a P. If you're desperate, your come along didn't arrive on time and you don't have any guide grips around, you can go ahead and use a dead end if you absolutely had to. If you're using a bolted dead end, those have shear head bolts, and once you've sheared off the heads, you've got to replace those bolts, or you could use a torque wrench after that, but that would be something of a big hassle. A U-bolt or a wedge type, um, you could use that, but then that's going to be a little bit more difficult to take off and move. A formed wire type dead end, an actual dead end as opposed to a grip, or a formed wire dead end designed for OPGW, you could use that, but then once you've used it as a working tool, the manufacturer is going to tell you it's no longer good for use as a permanent dead end, right? And the reason for that is that part of its holding strength comes from grit that's inside the formed wire part of the dead end, and you'll lose some of that in the process of using it as a tool. So it won't be able to develop full holding strength, which is why you can't then use it as a permanent dead end. Okay. Bad grips for string sagging and clipping in. So never use anything that looks like these pictures. Anything with an elliptical or a triangular shaped groove is verboten. Cannot use it. You'll see these called Chicago grips or pork chop grips or other terminologies, but if it looks like this, don't use it. Anti-rotation device, when do you need that? So for aluminum pipe type cable, you should always use an anti-rotation device. For your center stainless steel loose tube type designs, whether it's one with an aluminum pipe or aluminum cladding or just a plain steel tube, above about 15,000 feet or 4,500 meters, you should use an anti-rotation device. And type S cable, not required. Now, these are our guidelines. There are other cable suppliers who require an anti-rotation device on all of their cables. And because suppliers recommend different dimensions and weights for the anti-rotation device, you're in the situation where you have to check. You have to find out what your particular cable manufacturer's recommendations are. This is to illustrate what these things look like. This is a very simple one made from a length of chain, some rubber hose filled with lead shot, and you connect it to a swivel and to the pulling line, and then to the OPGW. Effectively, you're just connecting it. I say a dummy swivel, but that's just a way of saying you're connecting the chain to your Kellum's grip, which is connected to your cable. So what it's going to do is prevent the OPGW from twisting. If it's got any torque in the cable, it's trying to fight the torque. There are commercially available ones, and they're okay by NCAB. Again, you have to check with the cable manufacturer what they're going to allow, because here you see, if you total up what the weight of this is, it's what we would approve, but another manufacturer might want the weight to be different. So again, you got to check. The setup is also important. Every supplier is going to have a recommendation of the run versus the rise. We allow 1-to-1. So if my tower is 100 feet, we say the bull wheel tensioner should be 100 feet away from the tower. But some suppliers want more, 3-to-1. So 100 feet, they want 300 feet. So that's significant and affects your setup. And there are some suppliers who even say 4-to-1. So you've got to check. What pulling speed? I've said it before in this presentation, smooth. Use the speed that goes smoothly. So here are some rough guidelines. If you're using an ARD, you're only going to be able to go about 1 to 3 miles per hour. You're going to need to slow down at each structure and watch to make sure that that ARD passes through the block. Because if we go back, the ARD, as you go into a block, so if we would be going this way, this whole piece has got to pass over the surface of the stringing block, and then it will drop down once it clears the block. So you've got to be slow and careful during that process. After the device has cleared the block, then you can smoothly accelerate again. If you're not using an ARD, you can go a little bit faster, and you can keep going steady. As long as everything is going smoothly through the blocks, keep rolling. If you have to stop and then restart a pull, again, you want to ramp down the speed, and then when you resume the pull, you want to ramp it back up smoothly. Smooth, smooth, smooth. As I wrote here, no one likes a jerk, and that includes your OPGW. Temperature and time limits. So here are some guidelines. Again, guidelines, not laws. Minus 22, you won't catch me out at minus 22 anyway. To 122 in Texas, this is a reality. What can I say? Sagging. Now, people want guidelines. And what's going on here is if you finish a poll and it's like 5 o'clock, quitting time, um, people need to go home. So the thinking behind this 18 hours is that you've gone home and now you come back at 8 o'clock the following morning, but you don't get right to work. First, you got to have a cup of coffee, maybe fill out some intercompany reports, read your email, whatever. But so we wanted to put some limits on how long you leave the cable before you actually bring it up to sag. It's better to go ahead and do it immediately if you can. Just install the first and the last dead ends. Admittedly, unsecured cable is vulnerable, but if you didn't bring it up to sag, it had no securing anyway, right? You would just be tying off the cable somehow. So at least a first and a last dead end would give the cable more security than just it's somehow secured, tied off. But the concern is that if you leave a cable in the blocks too long, the cable immediately does begin to creep. So it begins the process, a long-term process of elongation. And the nature of that elongation is that you get a lot of it early on, and then it starts to diminish over time. It's the reason for the difference between initial tension and initial sag and final tension and final sag is this creep, this elongation over time. So if I leave a cable in the blocks too long and it's been elongating, well, now I can't actually do the sagging correctly because the initial sag chart that you use is assuming that the cable doesn't have any elongation. So then I end up with a situation, if it actually has elongated, then I can either get the tension right, but the sag will be wrong. It'll be greater than I think it was, or it was intended to be, designed for, or I can get the sag correct, but the tension is wrong. And specifically, the tension will be higher than I designed it to be and expected it to be. So you want to avoid that. So 18 hours, it's not a hard, fast rule. And we can adjust if there's some, bizarre situation that came up and you couldn't sag for longer than that. You should go to the OPGW supplier and they can help you out. You kind of look at some things, but it's about half dark magic and half science to estimate how much elongation might have occurred and how much to adjust the sagging charts that you'll be using. So just avoid that. Try to get it done within 18 hours. So then you got to put on the rest of the accessories, so the suspension units and everything else. How long do you have to do that? We recommend 48 hours. Again, this is not some kind of a hard, fast law of nature. It's the underlying concept, the things to worry about here is that unsecured cable is vulnerable, right? Nothing good can happen. Some bad things can happen. Um, I would at least try to secure the longer spans if I couldn't do this. Again, if it's a special case, talk to the manufacturer. They should be able to help you out, work out something that you agree. What about dampers? Well, 24 hours after this or 54 hours after sagging. Usually that's going to be done in conjunction with clipping in anyway, but again, people want guidelines, so here are some guidelines that are good ones to use. So we have completed talking about stringing. Next up is splice prep. But that's actually just a fake out, right? We're not going to talk about splice prep because we're already out of time, right? There's too much variation from one design type to another anyway, and the recommendations from cable suppliers and enclosure suppliers, they vary too much too. Just for now, know that that's the next step in the process. And the big challenge is to access fibers without damaging them right when you're doing it or leaving them vulnerable to damage during operation. So we are finished, and we're actually a little bit over time. So questions? If you want to talk, raise your hand or question. I'll look at, maybe people have been putting, and they have, questions in the comments or the chat rather. Okay. Will participants get a copy of the presentation slides? You have to ask for it, but yeah, here we go. So Alexis has helped me out there and answered that. So how does the angle from the reel to the first tower block factor into tension? It doesn't really. If we go back to like the setup, yeah, here we go. Oops, one too many. Here we go. So you can kind of imagine that what you see here, that you get the cable going across more bearing surface. And what I found is that the reason that we recommend 1-to-1 is that this is effectively like a 45-degree angle. And if you're not concerned about a 45-degree angle, why would you be concerned about it here? And so I have never seen the need for this 3-to-1 or 4-to-1 that I see some other companies use, because the tension is going to be the tension. And actually, I think it's even better that the cable, any consequence of that tension, like a pull down effect, the cable has more bearing surface when the rise to run is 1-to-1 versus it being, say, 3-to-1. So I've not really understood where my competitors have come from on this particular point, and I'll fall back on, again, my experience. What we recommend has worked well over the course of 30 years. So it's not, but in terms of that estimate that you use for estimating the maximum pulling tension, you're effectively ignoring any effect from that. So it's effectively assuming the friction of the block is the friction of the block, regardless of how much of it is engaged with the cable. That might not technically be true, but in reality, it works good enough. All right, so next, I see somebody posted my illustration, but I don't know the question. What is the maximum time you should allow between stringing the OPGW, sagging, clipping in? Okay, I think you anticipated what I covered in the last couple slides there, so I think I answered that already. What does the cable lay matter with formed wire grips? Oh, well, that's a good point, because a good question. Like if a grip is designed for left-hand cable, it's gonna get its maximum working tension with left-hand cable. If you use a right-hand lay grip on a left-hand lay cable, you're the outer wires of the cable, I'm trying to illustrate this with my hand, and the the wires of the grip are going to be concentric to each other like this. And you're going to develop less holding strength because you've got just point contacts between the elements comprising the outer layer and the grip, the wires, as opposed to the design being like this, where you're going to kind of maximize the surface contact and therefore the friction and therefore the holding strength of the grip. So it is true that you do need to use left-hand lay grips with left-hand lay cable and vice versa. So, okay, just general. What is the maximum line angle you can pull through without dead ending? Um, you can pull through 180 degrees. You can pull through it. Um, uh, you didn't have to double dead end. The way the accessories work is most suspension units are good for up to 30 degrees. And then you'll have a double suspension that's good for up to 60 degrees. And then after that, you can do a running dead end where the cable is dead ended, but not spliced. And so if you go back to those guidelines that I gave you before, closer to the beginning of the presentation, I'll go back. Ba, ba, ba. Angles. Wow, it really was the beginning. Yeah, if you go here, as long as you're meeting these guidelines, you're okay. So you you could do a 120-degree angle because one can be greater than or equal to 90 with an aluminum pipe type cable. You know, if everything else was straight, just for the sake of argument, because you didn't violate this and you're okay with this. So you can do that. I hope I answered that to your satisfaction. Do you see any issues with installing dampers, anti-galloping devices, or aerial FAA marker spheres during the pulling operation as opposed to installing them after the OPGW has been sagged clipped in? Well, I just don't know how you would practically do that because the cable is moving through. And if you installed a damper or an anti-galloping device or a marker ball, especially, they're not going to pass through blocks later on. I mean, if you happen to be doing them on the last span, or if you want to do them when you're doing the last span, I don't see any problem with that at all. But you'd have to plan accordingly. I don't have the capability of kind of illustrating what I mean here. I hope you understand me, but if you don't, you're welcome to follow up with me afterwards, and I could illustrate what I'm trying to explain here. But in general, on span 1, I couldn't put vibration dampers because they won't pass through the block to get to span 2. So you limit the ability. But like if you wanted, you get all the way to the next to the last span, and then back at span 2, you wanted to put a marker ball on and pull it to the middle of the span. Yeah, that's okay as long as you planned for it. I wouldn't have a problem with that. But installing dampers, same concept would work with anti-galloping devices. I think, again, you have to plan for it. And then with dampers, I don't think it works well with dampers because of the number that you have to install. But in theory, yeah, you might be able to make it work. Would this require any creep-corrected wire properties to model in PLS CAD to obtain an accurate sag chart? Yeah, absolutely. You would absolutely want to. Dampers, you could make the argument that you could ignore because the weight is the added weight as a percentage of the span is not that much, regardless of stock bridge or SVD type. Can't say that today for some reason. Marker balls is a different story. You absolutely have to factor in marker balls in your sag and tension calculations. And PLS CAD and South wire sag 10, I believe both give you the option of saying, am I factoring in the weight of these marker balls before I do the sagging or after I do the sagging? So I've completed the sagging and then I add the ball, or I add the ball and then I complete my sagging. I'm pretty sure that both programs can distinguish between those two situations. And so you would have to uh, uh, adjust your design accordingly. And then anti-galloping devices are somewhere in between. I'd have to say you need to look at the weight contribution there. I've not worked a lot with them. I suspect there's somewhere between a damper and a marker ball, and I'd have to think it through about at what point I would want to factor them into the sag and tension calculations. Yeah. So, did you encounter live line installation for retrofit or replacement repair? I've seen that a few times, the live line installation and also things like helicopter installation. I don't think it changes the basic principles that we've talked about today. I think live line installation does create concerns about the grounding that you would be using, and I didn't talk about grounding today in conjunction with this. I was basically talking basic 101 type cable installation principles, but grounding would be more of a concern. Question refers to total horizontal line angle calculation you discussed early on. Uh, 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 Not sure I understand what you're asking there. Some manufacturers specify a maximum number of structures you can pull through for a given section, which has caused us to install additional splice boxes. Does a low tension short span application change how you would apply the tension checks discussed earlier in the presentation? Okay, the different questions. A maximum number of structures that you can pull through. So yes, what they're doing is either trying to limit it's similar to what I talked about. They're basically baking in some assumed amount of added tension. And so saying that this is the maximum number of structures that you can pull through. So it's like I talked about how Wagner Smith has a different way of calculating the estimated maximum tension during the pull. I think it's a similar concept coming at it from a different way. I've tried to give you a general rule for determining the maximum numbers, right, of spans that you could pull through, because obviously it's going to, like in reality, the total number of spans or the number of structures is going to be related to the distance between the structures, given the total distance that you're trying to go through. And you'll notice that we didn't talk about that. We didn't necessarily say that you were limited to pulling only 20,000 feet, and it didn't matter if there were 10 structures or 100 structures. I gave you a math that said you can calculate what the tension difference is going to be and then determine if the pull is safe or not. Whereas another way of doing that would just be say, don't pull through more than X number of structures. I hope I've answered what you're getting at. If not, keep asking questions. Okay, does a low tension short span application change how you would apply the tension calculations or tension checks? No, it does not. What it does affect, though, is that when you come to me and ask for relief on block size, I do factor in the total length of a pole, because the reality is that the pulling 3,000 feet of cable is easier than pulling 30,000 feet of cable. And so if you need a little leeway on the stringing blocks for one reason or another, on a 3,000 foot pole, I'm likely going to say okay, But if it's a 30,000 foot pole, I'm going to say, no, you absolutely have to follow my minimum guidelines here. So that's how the length of a pole comes in. There's also a little bit more of, in the real world, there's a difference between a 3,000 foot pole that's through on exactly a straight line, and that 30,000 foot pole that's going through multiple angles. So the longest pole that I completed successfully in my career was 31,000 feet, and that went through 540, I think, roughly, um, total horizontal line angle change. Very unusual situation, and that's a case where I got heavily involved in the planning of the pole so that it was completed successfully. So again, hope I answered your question. Do you see any issues with installing dampers for tension to tension single span? Oh, if it's a single span, yeah, you could do that. I wouldn't object. Like especially if it's like a river crossing, yeah, absolutely. You won't, I wouldn't want to get in. What's that? My mind's drawing a blank on the term. They get like a little cart that goes along the cable. Man, you wouldn't get me in one of those carts. Maybe when I was younger, but now you wouldn't get me one of those carts to go across a, you know, 3,000 foot span crossing a river to go put marker balls on. Heck yeah, I would pause the pull, put a marker ball on, let it go, pause the pull again, put the second marker ball on, uh, keep pulling again. Absolutely, that's the way I would handle a span like that crossing a river where I got to put marker balls and other stuff on. Yeah, certainly. Okay, any other questions? Okay, well, appreciate the questions. I appreciate everybody's participation today. I hope I answered your questions. If I didn't, or do it very well, you're welcome to drop me an email later. Glad to help out. Again, a reminder, look for an email from us. There'll be a link where you can get see this presentation again. Maybe you're having trouble sleeping tonight, want to watch it again, go for it. You've also got reply to the email if you want an actual copy of the slides. Happy to give those out. And remember, there's a link to take the test if you want to get the continuing education credits. And then lastly, there's a link there to give us some feedback. We hope you enjoyed it. We appreciate feedback. And also, especially if you got ideas for topics, please let me know. And I appreciate the thank yous that I'm seeing. It's my pleasure to be here, share this time with you, and share my experience with you. Um, Always happy to help out too. So feel free to reach out. Thanks again, everybody. Have a great rest of your day.